Hello viewers, in today's class we are going to discuss yet another very important and conceptual problem from limits involving the fractional part function, right? So here we have a very important problem from limits, and here we have to evaluate this limit, that is the limit x tends to 0 minus, and here we have the sign of fractional part of x minus 1, right? So here this negative sign shows that we have to find the left hand limit of this function when x approaches to 0 from the left of x is equal to 0. So here let us take this limit as L, right? And here we can take this function as f of x, that is equal to sine of fractional part of x minus 1, right? And we have to find the left hand limit of this function, that is we can write limit x tends to 0 minus, and here we can write f of x, right? So we have here x is equal to 0, and we are approaching towards x is equal to 0 from the left of x is equal to 0, right? So let us take a point that is 0 minus h in the left neighborhood of x is equal to 0, right? So what we do here, we'll take x is equal to 0 minus h, right? Where h is a positive quantity and it is a very small quantity, and it lies between 0 and 1, right? So we'll take x is equal to 0 minus h. So 0 minus h is simply minus h, and here x tends to 0. So when x tends to 0, this implies that h also tends to 0, right? So now this limit L can be written as limit h tends to 0, and here we have f of minus h because x is equal to minus h, right? So now let us substitute the value of f of minus h, right? So here our function is f of x is equal to sine of fractional part of x minus h. So f of minus h is the sine of fractional part of minus h minus 1, because here we have taken x is equal to minus h, right? Okay. Now we have to make use of the definition of fractional part function, right? So now let us quickly see the definition of fractional part of, say, p, right? So the fractional part of p is defined as p minus the greatest integer of p, right? So here we have p is equal to minus h minus 1, right? So what we will do, we'll write here minus h minus 1, and here we have minus h minus 1, and here we have greatest integer of minus h minus 1, right? So what we have done here, we have taken p is equal to minus h minus 1, right? So now we can find out the value of this expression, that is greatest integer of minus h minus 1, right? When h tends to 0, right? So for this we'll take help of this inequality, and here h lies between 0 and 1, right? So let us multiply throughout by minus 1, right? So here we'll have 0, and when we multiply throughout by minus 1, the direction of the inequality get reversed. So here we have minus h, here we have minus 1, right? So this inequality can also be written as minus 1, and here we have minus h, and here we have 0, right? Okay, now see, here we have minus h minus 1. So what we will do, we'll add minus 1 throughout in this inequality, right? So what we will have, minus 1, then we have minus 1 minus h, and here we have minus 1 plus 0, right? So we have minus 2, here we have minus 1 minus h, and here we have minus 1, right? So this inequality suggests that minus 1 minus h, it lies between minus 2 and minus 1, right? So here we have minus h minus 1, which is same as minus 1 and minus h, right? So by definition of greatest integer function, the value of greatest integer of minus h minus 1 must be equal to minus 2. Why? Because this quantity minus h minus 1, it lies between minus 2 and minus 1, right? So from the definition of greatest integer function, the value of greatest integer of minus h minus 1 is equal to minus 2, right? So here we can take minus 2. So this quantity, that is fractional part of minus h minus 1, is now equal to minus h minus 1, and here we have a negative sign, and here we have minus 2, right? So this is the most important step, right? So now we can simplify it. So we have minus h minus 1, this is plus 2, and we have minus h, and 2 minus 1 is 1, right? So now we have established that the fractional part of minus h minus 1 is equal to minus h plus 1, which can be written as 1 minus h, right? Okay, so now let us return to our limit. So here we have the limit L is equal to limit and h tends to 0, and f of minus h is equal to sine of fractional part of minus h minus 1, right? Okay, so now the fractional part of minus h minus 1 is equal to 1 minus h, right? So we have limit h tends to 0, and here we have sine of 1 minus h, right? Okay, so now see here h tends to 0, and we have sine of 1 minus h. So when we take h is equal to 0 here, then we'll get sine of 1 minus 0, and that is equal to sine of 1, right? So what we have done here, we have limit h tends to 0, sine of 1 minus h, and we have taken h is equal to 0. Here we have sine 1 minus 0, that is equal to sine of 1, right? So the value of this limit is equal to sine of 1, right? So this is how we can solve these type of limits.